All right, we're coming to the end of our first chapter section in chapter 2 and power, chapter 2-1, power and radical functions. And in this chapter of power, polynomial, and rational functions. And this corresponds to page 91, example 6, where we're being asked to solve radical equations. Now, some of these are not too bad. Some of these can get a little bit on the hairy side. So we're going to start with a couple of more simple ones, and then we'll tackle one that's got a little bit more complexity to it. So let's look at this first one. We got 3x equals 3 plus the square root of 18x minus 18. Well, first we want to isolate the radical, and so in order to do that, we're going to subtract 3 from both sides, which is going to give us 3x minus 3 equals the square root of 18x minus 18. Now, we're going to square both sides of this equation. So we're going to square this 3x minus 3, and we're also going to square the square root of 18x minus 18. But in order to square the 3x minus 3, I'm going to have to FOIL that out. So over here, I'm going to do 3x minus 3 times 3x minus 3. And that's going to give me 9x squared. Probably could have factored the 3 out of that first. Might have made it a little bit easier, but oh well, whatever. Minus 9x. And then minus 9x again. And plus 9. Alright, so now I got 9x squared minus 18x plus 9. And when I square the square root of 18x minus 18, I'm going to be left with 18x minus 18. Now, I better put an x in there. 18x minus 18. Now I'm going to move all of this over to the left side of the equation, set the entire equation equal to 0. And let's see, that's going to give me 9x squared. And I got minus 18x minus 18x is going to be minus 36x. And plus 9 plus 18 plus 27 equals to 0. Now, everything in here is divisible by 9, so I'm going to factor out 9. It's going to leave me with x squared minus 4x plus 3, no, plus 9, yeah, plus 3 equals 0. And let's see, now I can factor x squared minus 4x plus 3, and that, if I factor that, is going to be x minus 3 times x minus 3. X minus 1, excuse me, x minus 1. X minus 3 times x minus 1 equals to 0. All right, let's see. So now we're going to set each of these factors equal to 0 and solve. That's how I'm going to do that right here. So I got x minus 3 equals 0. And x minus 1 equals 0. And that's going to leave me with x equals 3 and x equals 1. Now, I have to take both of these possible solutions for x and plug them into the original equation to see if both of them are actually solutions. So let's start doing that. So I got 3 times 3 equals 3 plus the square root of 18 times 3 minus 18. Okay, well 3 times 3 is 9 equals 3 plus the square root of 18 times 3, I believe, is 54. Let me double check that. Yeah, 54 minus 18. And that's going to give me 9 equals 3 plus, and 54 minus 18 is going to be 36. Square root of 36. And the principal square root of 36 is 6. So I got 9 equals 3 plus 6. And 9 does equal 9. So 3, x equals 3 is a valid solution. Let's try it with 1. So I got 3 times 1 equals 3 plus the square root of 18 times 1 minus 18. And so that's going to be 3 is equal to 3 plus 18 times 1 is 18 minus 18 is going to be the square root of 0. Well, the square root of 0 is 0. So 3 equals 3. And so both x, let me see, circle the wrong one. So x equals 3 and x equals 1 are both valid solutions, and I am going to represent my answer in this fashion. I'm going to use interval notation. And I can say that, well, I'm just going to put it in parentheses. Put it in a different color. My solution then is 1 and 3. All right, well, that one wasn't too bad. All right, let's take a look at the next one. Okay, well, this time we got the cube root of 4x plus 8 and then plus 3 equals 7. So I'm going to get my constants all on one side. So now I've got the cube root of 4x plus 8 equals, I'm going to subtract 3 from both sides, equals 4. And now I'm going to cube both sides of the equation. And so cubing the cube root of 4x plus 8 is just going to give me 4x plus 8. And let's see, 4 cubed, 4 times 4 is 16. 16 times 4 is 64. So 4 cubed is 64. And we can subtract 8 from both sides. So I've got 4x equals, let's see, 56. And we're going to divide both sides of the equation by 4. And when we do, x then is equal to 14. So that one wasn't too bad, but let's see. I do need to plug in x equals 14 into the original equation. So we got the cube root of 4 times 14, which we know is 56, plus 8, and then plus 3 equals 7. So we got the cube root of 56 plus 8 plus 3 equals 7. And 56 plus 8 is 64. So we got the cube root of 64 plus 3 equals 7. And 64, the cube root of 64 is 4 plus 3 equals 7. And 7 does in fact equal 7. And so our solution then is x equals 14. It's a valid solution, and we're good to go. All right, now we're going to look at one that's a little bit tougher. Hold on, have fun. Okay, so now we're solving a radical equation where we got the square root of x plus 7 equals 3 plus the square root of 2 minus x. Okay. This one looks to be fun. Well, we can start by squaring. We already got a radical isolated, so we can square both sides of the equation. And of course, over here on the left, when I square the square root of x plus 7, it's just going to leave me x plus 7. But on the right side, I'm going to have to FOIL this thing. And this is what makes this more fun. So I've got 3 plus square root of 2 minus x times 3 plus the square root of 2 minus x. All right, so 3 times 3 is 9, plus 3 times the square root of 2 minus x, and plus 3 times the square root of 2 minus x, and the square root of 2 minus x times the square root of 2 minus x is just going to leave me with plus 2 minus x. So let's combine some like terms here. So we've got 11 minus x plus 6 times square root of 2 minus x. Alright, so 11 minus x plus 6 square root of 2 minus x. So I've got a radical still on the right side, but I could move the 11 minus x over. So let's see, negative x, if I move it over, that's going to give me 2x, x plus x, 2x. And then I'm going to subtract 11 from both sides. 7 minus 11 is going to give me negative 4 equals 6 square root of 2 minus x. Alright, but now I've got to square both sides again. So I'm going to have to square 2x minus 4. And I'm going to have to square 6 times the square root of 2 minus x. Alright, so let's see. Let me get this one to see it a little bit better. Well, let me square 2x minus 4. Alright, so that's 4x squared minus 8x minus 8x plus 16. Alright, so we got 4x squared minus x minus 16x plus 16. And that's going to equal, so I'm going to square 6 times 6 is 36. And that's going to be times, the square roots are going to cancel, 2 minus x. Still having fun. Now I got to distribute the 36 to the 2 minus x, so I got 4x squared minus 16x plus 16 equals 36 times 2 is 72, and 36 times minus x, or negative x, is negative 36x. Now I'm going to set the equation equal to 0, so I'm going to subtract 72 and add 36x to both sides. So I still got 4x squared. Let's see, when I add 36 to 16, negative 16x, that's going to give me plus 20x. And when I subtract 16 from 70, that means I got 72 minus, 16 minus 72. Oh, that's going to give me negative 56. And that's going to now equal to 0. All right, well, I can factor out, I believe I can factor out a 4 from everything on the right side. And when I do, that's going to give me x squared minus, or plus 5x minus 14 equals 0. And now I need to factor x squared plus 5x minus 14. And I think that's going to be x plus 7 times x minus 2. Let's see. 7 times negative 2 is going to give me negative 14. That checks there. And 7x and negative 2x is going to give me 5x. That checks there. So yeah, that ought to work. Alright, so we got x plus 7 equals 0. And we got x minus 2 equals 0. Solve that. So I got x is equal to negative 7. And x is equal to 2. But I'm not finished. I've got to now plug in negative 7 in for x to the original equation, and then turn around and plug in 2 for x into the original equation, and see if both of them come up with a valid solution. But I don't have enough room on this slide to do that, so I'm going to save it for the next slide. Okay, so we had determined that we had two possible solutions where x is equal to -7 and x is equal to 2, I believe is what we had. And now I've got to plug this into both sides. So over here, that would give me the square root of -7 plus 7 equals 3 plus square root of 2 minus -7. Well, let's see, -7 plus 7, that'd give me the square root of 0 equals 3 plus 2 minus 7, that's 2 plus 7, that's the square root of 9. Well, square root of 0 is 0. And then we got 3 plus the square root of 9. Well, the square root of 9 is 3. And 0 does not equal 6. So it appears that -7 is not a solution. Let's see if 2 is a solution. So we got the plug in 2 for x. So I got 2 plus 7, square root of 2 plus 7 equals 3 plus the square root of 2 minus 2. Well, 2 plus 7 is 9, so I got the square root of 9 equals 3 plus 2 minus 2 is 0, square root of 0. Square root of 9 is 3 plus 3 plus 0. Well, 3 does equal 0. 3 does equal 3. So, x equals 2 is a valid solution, but x equals -7 is an extraneous solution. So my only solution here is 2. Alright, so I told you, a little bit hairy. Don't be afraid to use paper to solve your equations, because if you don't, you will get messed up. You solve for x, then you got to plug in those x values back into the original equation to see if those are an extraneous solution, and we just saw one where x equals -7 was in fact an extraneous solution. I love it.